but then it's only
Hello.
it's only 2 frames.
Oh, hi.
5.
Hello. Hey.
Hey, Narayana.
Hey. What's this?
Is it gonna work for me?
Oh, okay. Good. So we have everybody today, I suppose, the usual group.
Yeah, hold on one sec. We're trying to resolve some technical difficulties.
Oh, okay. Yeah, I'll come next week. I just couldn't come today.
I might just AirPlay it. Can I see the remote?
Oh.
All right, can you hear us?
Oh yeah, I can hear you very well.
Narayana?
Yeah, I'm able to hear you guys. There was a... I think Deek just posted a YouTube. Is that something you guys are talking about, or?
Can you play something else?
Are you
Are you using AirPlay or something? What is
Yeah, I just switched to AirPlay.
So you don't have volume, maybe?
Maybe. Is the volume on the TV on?
Ah.
Okay. Narayana?
Yeah.
Oh, okay,
Oh, there you go.
there we go. All right, I think we're all set.
Oh, you weren't hearing me all this time?
No, yeah. No, we haven't heard you until just now.
Oh. Oh, I was asking, Deek just posted a YouTube thing. Are you guys looking at it, or?
Yeah, that's a thing I used when I was learning, but that's too. But it is helpful if you.
Which one is this?
This is YouTube course, not course, a bunch of videos that kind of help you build use YOLO.
Where?
I put it in Slack.
He put it in the Slack, just a list of our names instead of.
Oh,
learning with the D?
Yeah,
I
learning.
mean, yeah.
So now you put.
And I think your name isn't on that.
Okay.
Wisdom.
That's okay.
Names.
Yeah, I don't know how useful it'll be. This is for YOLO too, anyway. But yeah, it's
I mean, is YOLO coming back? Remember, I mean, Jeremy used to talk about it in his deep learning course too, the YOLO versus the other one. And then he said that's what they've gone. I mean, YOLO and these two techniques came at the same time. And then they said, okay, seems to perform better, and people went with that. I forget the name of the other one, the YOLO versus the other one for the bounding boxes and stuff.
Yeah, I think it's SSD.
Oh yeah, SSD. Yeah.
Yeah, and I think it's a trade-off of performance versus accuracy.
A bunch of keys. A video.
Yeah. But it's YOLO too. That's
Yeah, I haven't seen these. Does it go into like lots of detail?
Yeah, it's pretty good. Got me able to do a bunch of stuff. Yeah, this is the older version. They should have newer videos for you to look through.
So do they say how they did it? I mean, this is like actually a car, like a video. They're doing it on a video.
Yeah. Yeah, I was able to use this and then do it on a Fast and the Furious clip. It was very good. It was really fast.
Oh, on video?
Yeah.
This can do it on the video also.
Yeah.
Oh, that's.
Oh, so you downloaded the code and ran it on a video that you had?
Yeah, I ran it on a movie clip, Fast and the Furious movie clip.
And I was just showing before you joined a real-time, or I guess near real-time detection from a webcam, right from the computer.
What is it, aerial detection from a webcam or?
No, near real-time. It supports like 5 frames per second if you want any good accuracy, but it's running on a CPU on a local machine. So detecting objects right in front and with the computers, with the laptop's webcam.
Oh, with the laptop's webcam. So this is like what like Amazon trying to sell their deep lens and stuff. They are trying to, I mean, this is already, you can just use your own camera then, basically. Remember the deep lens, you have to buy their thing, and then that'll detect, that has the hardware and the link up to their AWS to do this detection and stuff.
Oh yeah, no, but this was running locally.
Wow, okay.
I'll paste the link to it. The repo has everything you need to like get started.
It shows the same thing. It shows the confidence numbers too. Are you able to see that?
They're not passed, but I was going to add them, but didn't have time. I was a conference all week last week, so.
Strange Loop.
No, spring one.
What's that about? Spring?
Spring.
Spring.
Java stuff.
Hmm?
Java.
Did any of you guys go to
Java,
Strange
cloud.
Loop?
What's that?
Did anyone go to Strange Loop?
I went to Strange Loop last year, but this year it conflicted.
Yeah, I didn't go either. I was just curious if there's anything.
Spring One platform. That's a conference. Around 3,000 or 4,000 people.
It's a good amount.
Yeah, I've never heard of that.
So Spring,
It's like a
like
framework, right?
they make Rabbit. Pivotal makes Rabbit. Thank you. They're the number one committer for Rabbit.
Oh, okay.
The open source version. They make, well, Spring Boot, and all of that Spring injection stuff. That's Pivotal.
Is that, okay, so Pivotal makes Spring or?
Yeah, I mean Spring is open source, but
Yeah, they're the main.
they are the
Backers.
the enterprise, for enterprise support, and they are the largest committer for it.
Gotcha. I always think of Spring as being it's a web framework, right? Or mistaken. Okay.
Web, microservice. I mean,
My Java ignorance is pretty bad. Sorry.
a lot of cloud enablement,
Gotcha.
putting your stuff in the cloud, and then Gemfire.
So can you share that link?
For what? For YOLO?
Not for YOLO. YOLO Deek has already shared it. I think David has now put it in the learning in the deep. The other one you were talking about.
Oh, the Spring.
From the CPU for just the image. I mean, using the camera and the CPU itself.
Yeah, that's also YOLO. It's just running.
It's using YOLO. I'm running it locally. Yeah, I was just copying the link. I just didn't get it. Yeah.
Oh, it's the same link that.
No, it's somebody else wrote YOLO in Python or in
PyTorch, I
PyTorch.
guess.
Yeah. I think it's somebody else. Maybe it's the same person.
Yeah, so it's a different link, isn't it, to go there?
Was it PyTorch YOLO version 3?
Yeah, that one.
Okay.
Yeah, I think that's a different person.
Hold on.
I don't have it
Or
open.
did I do the right one? I just dumped it in the channel.
General?
In the, oh, sorry, this is Learning in the Deep? Yeah.
Yeah, that's fine.
General channel?
Yeah, that's fine.
That's good.
Yeah, I was just like, there's like, I guess, the big competition is TensorFlow and PyTorch. Apparently everything else is slowly
Yeah, the thing is, if you want to
going
run,
away. I was surprised that even MXNet was not as popular. I mean, those benchmarks on that video that was showing TensorFlow 2.0.
Yeah. Yeah, I didn't hear them mention anybody but PyTorch.
Yeah, it was either PyTorch or TensorFlow, and everything else is.
Yeah.
Yeah, that article was really, I mean, they were going after PyTorch all the whole way there. And
The author was
provide the segue for us to switch to TensorFlow. Once they do that, it becomes, I mean, it's just got to become easier to debug and stuff. Can't have a static graph and then do all these sessions and stuff when you're just trying to experiment with stuff. That was the thing they were talking about, where the eagle loading is the default version now, and Pythonic way, and the Pythonic way they were talking about the graph. What is it? The autograph or something like that, and so that you're not trying to do all that stuff. And,
is there any mention of training in this repo? Because I went through this guy's Medium blog posts about YOLO v3 from scratch, thinking that at some point he's going to talk about the loss function and training. But he just never talks about training. It's just, here's how you can download the pre-trained weights from YOLO and put them into a network that runs in PyTorch.
Oh, really?
Yeah, yeah. So yeah, I don't think this covers the training aspect at all.
okay.
Oh, so he has a link to the paper, but nothing else. Is that the code?
Oh yeah, yeah.
What about the Katie Nuggets one? He talks about a little bit of.
Yeah, Katie Nuggets may be a tutorial.
I guess he has it as part 1, maybe part 2.
Oh, it's a single.
I guess so. Part.
Yeah,
Am I
but
looking at the right blog post? Or?
yeah, it's like 4-part thing, right?
Yeah.
Yeah.
So here he actually talks about training, creating the layers and all that stuff, and forward pass. And...
Yeah, he talks about forward pass, but he never talks about training.
Oh, okay.
Yeah, this is all just how you run it through, and you can use it to label your stuff. You need to run the forward pass to do that. But yeah, I kept waiting. Oh yeah, part 3 is gonna have it. No, part 4 is gonna have it. No, it just ends in part 4. But
Okay.
Like military, maybe the military stopped doing that.
But isn't it just a matter of us training it? I mean, we can always train it once the architecture is there, the layer of the architecture. Okay, if he doesn't train it, we can always train it.
Oh, the author is working on the full tutorial on the training component itself. Should be out soon.
Oh,
the 22nd of May.
Oh.
soon. This is a vaporware.
Because he may not want to go around, okay, creating the learning rates, creating the loop, all that stuff, and checkpoints and all that stuff to train it. And he just says, okay, here it is, implementing the forward pass. I'll show you how this works. I mean, if you want to train it, you guys write the code to train it.
Yeah. It was in my lab.
I know.
Oh, okay.
Are you coming tomorrow?
I get 1 night out a week. This is it.
I'll tell him
what's
that
that?
I get to meet you.
What's that?
I'll tell him that I get to meet you
Yeah.
every week.
Yeah, I talked to him for a while, trying to get on that online. Yeah, he's a nice guy.
I miss the food guy. It's just not the same as Whenever.
How much time is left on this competition, Lorena? I haven't heard any.
20 days. Yeah, 20 days. I haven't done anything. I just doing other things during the weekend. I haven't done anything. Basically, now I'm like, you can't, I mean, everybody knows how to blow this through, I think. Now I'm like 1,000th place or something. Okay. So I haven't gone back and did anything. So.
Is this the mines one still, or something different?
Yeah, it's the salt
Mine, yeah.
Yeah. It's about 20 days left on that. Maybe this weekend, I just couldn't do anything this weekend. I was thinking maybe the coming weekend I could do something, just not.
And I heard that you're gonna start looking for a new job.
Well, I was thinking about it. I mean, I'm starting to, yeah, I was talking to Deke about it and stuff.
Sorry, I didn't know what I was supposed to tell.
Yeah. We're all friends here.
Yeah, it doesn't matter. I mean, okay, you guys know I'm looking for something in that area, but I'm just talking to, I mean, I'm looking at various options here. I just want to, I mean, I'm talking to right now, I'm talking to Deloitte to see if there is options through their consulting arm and stuff going through that way. So that to get exposed to a lot more stuff in the consulting way rather than stick to some one company. So we'll have to see how this thing will play out. But anyway,
Do you have an advanced degree, Narayana? Do you have an advanced degree?
Yeah.
You have a PhD?
Yeah.
Oh, okay. Well, I didn't know. I couldn't remember based on our previous conversations. You might want to reach out to, if they still have job openings out of MasterCard. The guy I talked to out of MasterCard was really interested in hiring people with PhDs and like finding positions or inventing positions that like make sense for them. So, you know, you have a lot of passion for this, and then like on their side, I think they want to hire people with passion and a PhD.
Okay. Do you know that guy? Do you have any contact address of that guy?
Yeah, I know them personally. Yeah.
Oh, you know him personally? Okay.
And what about Hayden White, the recruiter? She was one.
I haven't talked to her. The other one I saw, it's like a startup. I'm still kind of way okay.
Yeah.
I haven't even talked to her, and that was requiring so much experience and stuff. So I haven't talked to, but I haven't talked to Peyton White either yet.
Okay. She was just wondering. So no problem.
Yeah. So I don't know what. Oh, if you know him personally, then I'll reach out to you.
Yeah, I only had one conversation with Chris Mares.
Yep.
But he was really cool to talk to. And then I accidentally let slip during the middle of the conversation. I just said something about semi-supervised and unsupervised, and he was like, you know, by the way, I coined the term semi-supervised back in 1982 or 92 or something like that. I was like, really? And then I went and looked it up. It's true. He's been around. Like, it's the real deal.
Oh, it is true that the guy has hung around MasterCard since that time?
No, he used to teach.
Oh,
I think he might still be teaching sometimes in Rala. I don't know. Maybe some online courses like.
But he's been doing machine learning for a really long time.
Yeah.
Oh, okay. I mean, if he can say, hey, I coined the word semi-supervised, that's kind of interesting.
What's that?
I mean, if he can say, I coined the word semi-supervised, that's interesting.
Yeah. No, he was really fun to talk to because, like, I was getting really demoralized at the job market in St. Louis for deep learning, and people just, like, wanted you to have the checkbox of, 2+ years of data science or whatever, and this guy was way more interested in, like, can you learn things, and using a PhD as a proxy for, yes, you can learn things.
Yeah.
And, are you passionate about stuff?
Okay. Yeah, I'll...
I would have definitely spent more time talking to him, but timing didn't work out with all the, like, those two things ripened up at basically the same time.
Okay. So one more thing was I was going to present at UMSL next week. Stephanie reached out to me on, I mean, they wanted general stuff. So I don't even know. They're saying, well, this is a, what did they say? What did this group of, the contact person, I was just going to show you guys what I was going to cover in general. I was thinking of, I didn't want to go too deep or anything. I didn't want to go and bother them with a lot of equations and stuff.
Who is the audience? Like, are these advanced students, or is it like a?
That's the I mean, I asked them about it, and what did they say? I asked them about it. Like, students can vary from freshman to graduate level. Well, that means it's like, okay, the whole, it could be anybody. They mostly likely do not know a whole lot. This is what the contact person at UMSL wrote. And we allot 60 minutes for the speaker. So just a basic understanding of AI and how it is emerging into technology would be great. Okay, so it's like a very general thing. And pull up some stuff.
Yeah, so I remember you in chat were saying that you couldn't show a video or whatever. That video that I have is only like 4 minutes long.
So okay.
You go ahead and click on it and see if you like it. Wait, the video I sent you was my whole slide thing, but there's a video link at the bottom of the README that I sent you.
Oh, okay.
And
no, there is a Meetup 35. What is deep? Okay, that's the video you sent of the thing. Okay. So you are saying
you're not sharing your screen, by the way. I don't know if you want.
Oh yeah, yeah. I'm gonna share it now. In a minute.
I don't have to do anything to that.
No.
Oh boy. Okay.
But yeah, there's a guy called 3 Blue 1 Brown or something like that, and he just does like really great visualizations. And I found he did one on neural networks. He did a couple of them on neural networks. So I just stole like about 4 minutes of that.
Oh, this one. Okay.
Yeah.
I didn't probably see this. This is probably I can.
Yeah, that's the guy. He used to do it for Khan Academy.
Yeah, I watched one of these.
I like his linear algebra series.
But I think you'll find that this helps you to like explain things that otherwise are just hard to explain. Like set the stage a little bit. Like what is a neural network and why do they have layers and stuff like that.
Okay, no, this is cool. Then I'll incorporate that then. This is very visual.
Mm-hmm. Yeah, that's the whole video, but I think I have a version of it that I just clipped down to like 4 minutes.
Yeah, this is like 20 minutes. I can't show 20 minutes, so I gotta.
Yeah. No, I used a little tool that I just found on the internet to take a YouTube video and chop it down to specific time points. And mine is only like 4 minutes long. I can.
Do you have to download, or it just makes you a playlist that actually?
Oh no, it downloads it to you.
Do you have the copy handy?
I do. Let me see how big it is. If it's really small, I'll just add it to Slack.
Okay. I mean, the Slack, since we have our own channel, we should be able to push more bigger files now on Slack. So yeah, I need to, I mean, I haven't formatted and stuff, but I was going to cover, okay, what's AI, what's the general use of AI and stuff, and like at least tell them, hey, narrow AI and general AI, and what we are doing is narrow AI. What we do. and what is machine learning, a little bit. I mean, I need to cut it. I need to format it stuff. I need to cut out a lot of sentences. I was copying from here and there, trying to say, hey, what is the resurgence? What's fueling resurgence? And then, hey, what is supervised learning? And like there are semi-supervised learning. I just remembered I need to, I need to cut down these. They won't know what a GAN is, okay? It's like, I need to fill in more things into what a semi-supervised, basically, hey, where system can learn how to carry on tasks is far smaller amount, the semi-supervised learning, then the unsupervised learning. But I thought this was a good thing. One thing I saw was, and then what are the different techniques in supervised, unsupervised, and what is a traditional machine learning? What do we do on traditional machine learning? And one thing I did want to cover was this bias variance trade-off, which I wanted to show, hey, you can overfit, you can underfit, or a good balance. And why is that important? I mean, just showing, hey, supervised machine learning, this is underfitting, it's got this is just right, but then you can keep overfitting and get it right, but then your total error kind of, hey, as you, in the traditional thing is, as the bias goes down, the variance starts creeping up, but you want to stop somewhere so that your total error is at this point, minimal point. Where I want the Fukushima plant, I found some information about this. I don't know if you guys have heard about this. I saw it some website, they were talking about this. Hey, what these guys did was, they were doing this, designing the power plant, engineers had how often earthquakes would occur. I don't know what this law is, but it seems this law gives them the ability to predict probability of a very strong earthquake from frequency of very, very, very weak earthquakes. And so the relationship was that the magnitude of the earthquake and the logarithm of the probabilities happens as linear. But what these guys did was, instead of fitting a curve, a linear curve, they went and overfitted this thing and hugs the data. In fact, their model makes a kink at around magnitude of 7.3. It is really not linear overfitting. So what happens with the overfitting is, if they had not overfitted it, they would have gotten this this line. And this was what happened was, since they overfitted that line, the accurate prediction was like the 2000 devastated, because they only built it for 8.6 magnitude, because they thought a 9.0 magnitude is a 12,700 year occurrence. Okay, but if they had gone with the 9.09, what did they say here? Yeah, the overfitted model predicted that one earthquake at least magnitude 9 about 13,000 years. Yeah. Well, the correct model would predict one earthquake of at least magnitude about every 300 years. So, which means they went and used this overfitted line, and they only built the nuclear power plant to a magnitude of 8.6, and we know what happened after that the earthquake happened. So it was just interesting tidbit that, hey, how when we are trying to predict things and stuff, we need to be very careful about overfitting data. We need to be careful about this thing of, hey, yeah, I don't want to underfit, but I also don't want to overfit.
I uploaded the video to Slack.
Oh, okay.
Should be in the general channel.
That's log scale, so a little makes a big difference.
Mm-hmm.
Yeah, because it's a log scale, it makes a huge difference.
But if anybody would have plotted it, you probably would have. You don't need machine learning to know that. Probably should just go linear on that.
Maybe there was some mechanism that they thought was like causing it to trail off.
Yeah, I mean.
Well, the statistics get bad too, because
Yeah.
the really
like
powerful earthquakes, you only have like 2 data points. So they weighted those very last 2 data points way too much.
If you just like even charted by hand.
This is from 2012?
And this is something I got from you, David.
Go back to your graph though, like the
2012,
was
yeah.
silver 2012 or something?
Yeah, 2012.
Wow. Seems relatively more recent than
2011 earthquake, they say, 2011.
why they underbuilt.
This was analyzed in 2012. This guy analyzed in 2012, but it was 2011 earthquake.
Okay, this is, doesn't mean Fukushima was before 2012.
Yeah, this is them analyzing why they built the plant.
Okay.
Underbuilt it.
Why this being screwed up?
And then I wanted to share with them, hey, data made deal happen, a little bit of, hey, what happened there.
Well, we don't have to worry about this for 12,000 years.
Yeah.
I wouldn't take the chances on even every 12,000 years.
Yeah,
Well,
that's
even
still
like,
something
what was
to,
it? The Chesterfield Valley thing, the flood.
Yeah.
It was especially like they expect a flood like what happened in 1993 to happen once every 100 years. So
On average.
on average.
But it could happen next year.
Exactly.
and that number only goes up too because you keep putting like more sediment in the channel,
Channel.
so that it like
Yeah,
keeps
yeah,
increasing in
yeah.
probability as you move forward.
Previous results
Yeah.
are not indicative of
Yeah.
future behavior.
Well, we're overdue for Yellowstone.
If Yellowstone happens.
We're all screwed. That
There's no
Unless-
contingency.
Musk gets us to Mars before the.
Yeah.
So it's all on people.
The whole world's screwed? Or just
no.
North America?
No, the whole world.
Certainly all of Missouri.
You have all the.
And then I was going to end my thing with the AI and democracy and say what happened here, hey, Cambridge Analytica and stuff, and what they did was micro-targeting technique, and we still have to be very careful about this.
That's way too much writing for beginners, Mariana.
Yeah.
Yeah, and if you're already on like slide 61 with that much
Yeah.
text,
No,
I know you
some of them are already hidden, but
I
you need
think
like
your bottom side just needs to put down to one.
you need like one sentence per slide max.
And you can have like one thing, just ethics.
I'm going to cut it out. Initially, I did a lot of stuff. I mean, I will at least cut half of the slides out. I just wanted to kind of see what is important and what is, I mean, you just throw it first in, a lot of stuff. But I didn't want to kind of go into, okay, like deep learning, the learning. I mean, not going to too much detail other than say, hey, other than what David Bullitt said. And then even image recognition, I'm going to replace all those bullets with just one picture, basically.
oh, okay.
I'm going to do that. Even translation, I'm going to say, I'm just going to replace it with a picture. Hey, this is what happens or something. So I'm not going to have all this stuff. I mean, I'm just trying to put something in like healthcare. I'm going to have a picture there. So that there's no point having all these bullets and stuff on it. And
I don't know if you want to end on a positive story, others are going to leave. AI is bad, AI sucks. I don't know. we want them to leave with, wanting to.
Well, the Fukushima thing wasn't due to AI.
No, well, the last part is the Facebook fiasco.
Yeah,
Yeah.
Facebook thing. I mean, but that's real, guy. I mean, they need to understand, okay, all this AI, all this stuff, whatever you guys, but we need to protect our democracy. Okay, in some fashion or the other.
It has nothing to do with it.
Yeah, I guess. I mean, they can use the data.
Well, you're hitting this like
So-
you're sort of hitting the boundary of AI and data science. Like
The Cambridge Analytica people were using AI to
they're using machine
build
learning.
profiles of
Right.
Sure.
But I think, I sort of, like I separate AI versus data science. Like AI, I'm thinking like you want some machine to predict or do something for you. You don't really care how, you just want something to be done. Whereas data science, I sort of interpret as like you're trying to gain insight into a process or a phenomenon or something. And you're just trying to gain more knowledge about it. You don't really care about the action itself. That's just my opinion though.
Well, either way,
too.
we need data for AI, like, because that's the whole reason the Chinese are like, trying to dominate because they have access to all this data. So,
Yeah.
But yeah, I mean, yeah.
Didn't they just?
I mean, this may be also too much for them, surpassing human level performance. I was trying to make the point, hey, we can, I'm gonna get rid of a bunch of, I mean, at least I need to get rid of half the slides, basically.
How long is the presentation?
60 minutes.
Yeah, what's the
Do you,
rule?
does that
Like,
include
2
question and
minutes per
answers
slide
too, or is that excluding a question and answer session?
I don't know. They said it's 6. I mean, they said they give the speaker 60 minutes, so I don't know if it includes. I gotta ask them. But I mean, a bunch of the stuff here, I put it. It'll all be replaced by pictures, so that I just don't have bullets and stuff. I'm not gonna talk through bullets and stuff through them, and maybe a few bullets first. Hey, what is AI, and or what is the general use of AI? But then use this where you have posted. You said you posted that video, so
It's not processed yet or not uploaded.
It should be there. It shows online.
Is this what
just-
you gave for the web developer meetup?
It
oh, I
just-
just downloaded it.
I did it full stack.
Okay, I just downloaded it.
I think they uploaded to Facebook or to YouTube themselves. So
What's that?
they don't host it; they upload it to YouTube. Like probably their private YouTube.
Yeah. Oh.
Probably what's going on here.
But yeah, it's only 4 minutes.
Yeah, no, this is good. 4 minutes.
And it basically talks about like feature engineering and what is it doing to try to recognize a digit.
No, that's good. I've downloaded that. Yeah, this is probably too much for them. I just need to, I mean, have 3 bullets on a slide and that's it. This is all. I was just trying to collect some information. Hey, what can I put on this stuff and things, and even supervised learning. I just don't want to get there too much into supervised learning. I mean, this is all too much verbiage. I got to get rid of this. All I need is supervised learning, some picture of supervised learning, what supervised learning means and stuff. So I need to get into images rather than bullets in a lot of stuff.
The general gist, you're going from supervised to, I guess, examples and ethics. When is this presentation that you have to do?
Next Tuesday.
You could do the, I remember in scikit-learn, somewhere in there, they have a graph of the various types of machine learning algorithms.
Mm.
Graph was, sorry, I don't remember that offhand.
Yeah, it's like a machine learning cheat sheet.
Yeah.
Like it's this kind of problem, and then go down this branch.
Right.
Yeah.
That was great.
Machine learning map, or is it a cheat sheet?
Scikit-learn.
It's kind of both.
This one?
Yeah.
Yeah, this is the classic one. Yeah.
There you go.
Kind of defines what
Yeah.
algorithms solve what problems.
Yeah.
But it's really, yeah, it's pretty like you have to want to solve one of those problems to care about this map a little bit.
Right, this is just the general family, like, regression versus classification versus
Yeah.
dimensionality reduction. I forget what the other ones are.
Clustering. Yeah.
I guess it doesn't have the branch for Bayesian thinking, but that point.
Yeah, clustering, classification.
Bayesian
I mean,
stuff.
into the traditional machine learning. Hey, there's
I heard there's like Bayesian deep learning. I'm not sure how that implies what that means. Like if you look, there's a Python module called Edward. It's called. If you look, search for Python and Edward. I guess a Bayesian Bayesian probabilistic programming language type thing. So it's using Bayesian inference.
Interesting.
But then they had a section in there talking about Bayesian neural networks, Bayesian deep learning. I get to get around reading that now.
It's like how they were using like random forest for deep learning too. And that one paper. Yeah. Yeah, I feel like the definition of deep learning is like
Yeah. I'm not sure like how could it be Bayesian? I don't know. They had like priors in the weights or something. I don't know.
yeah, like setting the weights based on
Priors.
Yeah, I think it's just like a bit of a buzzword. If you really want to get published in certain journals, throw Bayesian in there. Like,
yeah.
Right. But I mean, like, there's a whole other, like, I mean, still the Bayesian techniques are like a whole other set of things unto themselves. That's for sure. I mean, they're just before they were like impossible to do because just computationally intractable. I think it's slowing down. A lot of those ideas are coming back because they can actually do.
yeah, that rhymes with deep learning in general.
Yeah, I'm going to replace all this with something. I'll do it tomorrow night or something. Just replace a bunch of those slides with just pictures. I mean, it's easy to talk about and people understand what the pictures mean.
So did you guys read the article about the guy who won the particle detection or the particle tracing Kaggle competition?
No.
No.
Yeah, it came in one of the just Kaggle news updates that I saw. But the competition was over the summer, and it's over now. The guy who won first place described in the long interview like what his strategy was. It turned out that it wasn't really very deep learning. Like there was a little bit of like a shallow network involved, but mostly it was like modeling and stuff.
domain knowledge and stuff like that.
How even more just like just heuristic search kind of stuff. Yeah.
Was it like ensemble method kind of things you're talking about? So at one point, like I remember, like there was one point, like back in the day, like I see all the Kaggle winners are just basically ensemble methods, like random forests or.
Oh no, his was very tailored to this particular competition. And like at first, he was just like he wrote a little detector. Like I don't know if it qualifies as deep learning. I think there's only like 4 layers or something, but it was just a pairwise track classifier. Given any 2 pairs of points, are they in the same track? Do you guys remember the competition? I don't know if we talked about it here, but at the Large Hadron Collider, they've got protons that shoot at each other close to the speed of light, and then they've got detectors, silicon detectors in a cylinder around the collision sites. And then those detectors detect a charge deposition onto the site and a timestamp. So they have like an XY coordinate and a timestamp. And so based on all of that data, they want to find a charged particle like going in a spiral because there's like a huge magnetic field there, so they call them spirals. And so like there's a spiral that you can then infer back what was the mass of that particle. And so they have all this data that is just, you know, at this XY position at this time, this much charge was deposited. And so then, and they've labeled a bunch of them with, you know, all the tracks. That's what they call them, the little spirals, the tracks. And so he started out with just pairwise, can I determine if you give me 2 pairs of points, whether or not they were in the same track? and he could get like 99.5% accurate on that. But the problem is there's like 400,000 points in each data like run. And so even with 99.5% accuracy, it's like terrible. Like you couldn't reconstruct the tracks at all. And so then the rest of it was just after I get it down to 99.5, then going through and like throwing out all the false positives and then reconstructing the tracks. Like,
how does he identify the false? I guess he has the answers.
Yeah, so like, I mean, if you have a couple of them, then you can say like, you know, these other ones up here aren't consistent with the track that was consistent with these ones. And then you can basically go through and find all of them that are, find the most of them that are consistent with each other and say, yes, that's a track. So it's just a big search problem with some like conditions that you have to like understand the physics a little bit. Anyway, it was just kind of sad that in the end, deep learning wasn't the thing for that. And he even mentions at the end, he was just like, I thought it was going to be deep learning, and then it wasn't.
Did he try like deep learning stuff too? It just wasn't performing that well, or did he just not need to go in that direction?
I don't know. I spent like a half a day just trying to figure out how am I going to turn this, like the way that the problem is formulated into a deep learnable like problem, and I couldn't figure anything out. I didn't try the brute force thing he was doing, which is like pairwise, whether or not it's in the same track, because that seemed like
Take a while.
that's insane, the number of pairwise comparisons you'd have to do. But
Yeah, it's like he beat everybody by a good margin.
He was top quark.
yeah,
Awesome name.
yeah. Anyway, it's a fun read. You guys should read it.
Yeah, I mean, you see the thing, that's pretty, I mean, 0.92, and by the time you get to the sixth guy or something, it's 0.83. I mean, there's a huge gap between the, like the top performers and like within 5 or 6.
Yeah, it's a really hard competition.
Yeah, and after that, I mean, 8.3, 7.6. I mean, you don't normally in a competition, it'll be like within that third, fourth digit or something like that.
Well, part of the reason it was so hard is that it wasn't sort of like tailor-made for machine learning algorithms. It was like the data is like raw out of these detectors, and they're like, "Can you do this really hard problem?" So,
The number of submissions are pretty low too,
yeah,
compared to other competitions.
yeah, and it was $100,000.
He has 10 submissions. That's it.
Oh yeah, that's what you mean. Yeah, yeah, I'm sure he was doing way more than that at home, but he only submitted 10 times for evaluation.
I guess some of them are more prone to that.
Well, I think it's really expensive too, like to do a
It's not
submission.
even 100,000. There was only $25,000 prize money for this.
Like one submission a week or something.
Oh, okay, they don't let too much.
No, I mean, it's just that there's that much data to determine all the track candidates or whatever.
Oh, okay.
It's how much time it took, like on his machine. It took like a week to come up with a submission, yeah.
It's a good thing you kind of got it right early. You can't really iterate if it takes you a week.
Yeah.
Oh, Deke, did you tell them about your problem that you're working on, or? Is this...
Yeah, a little bit. I was actually going to ask you about your suggestion. I mean, I think that's a pretty good idea. Only thing is, so if I'm building separate models for the holidays, if each of the behavior of each holiday is different, then I would have to build separate models for each holiday, right?
If it is, I don't know. That's why you start off with the thing to see, start with all the holidays, see if it is, how good can it fit, and then we can start thinking, okay, if it doesn't fit, then what do we do now? But I was going to ask you one thing, was how did you have a validation set separate from the training set that you are able to validate on?
Yeah, I had a training set and then a test set where I can test it out or validate.
Okay, so that was the data that the thing never saw, that the model had never seen, because the graphs you were showing on that day was on
Right,
the
yeah, that was the graphs that I showed.
Okay, so that model had not seen those CPU before.
Yeah, I had 4 years of data. 80% was training, I think 80, and then 20% was the validation testing.
Okay, but how did you, was it overfitting, underfitting? I mean, what did you see? Was it, how close was the validation error versus the training error?
Yeah, that's the thing. I had the training loss, but I need to re-engineer. I didn't re-engineer it so you can actually get the training loss. Sorry, test loss. Because of the way I wasn't getting that value actually. So I'm needing to redo it to be able to see.
Yeah, you need to figure out what the test loss is.
Yeah, sorry, test loss. Right.
Because, well, you're talking only the test data which you're testing after you've trained the model fully. But during your training itself, do you have a training and a validation set?
No, that's the thing. I actually built this based on a Udemy tutorial, and this is how he did it. He didn't have in the training, he didn't have a test and training to be able to see the test loss.
Yeah, you need to do it together so that you know what is going on with your model.
Right,
is it overfitting, underfitting, where you are? Unless you have the model applied on your, whatever you call it, the validation or test. I mean, once you go forward one epoch, you got to apply, I mean, do a forward pass on the validation set to see how it performs on it.
Right.
So that you know where you are on the training.
How did you split the data out?
So the first 80%, so first 80% of the dates is training, and then the last is test.
Okay.
Yeah. So it's predicting on the last couple months, or yeah, about.
And how much of a time period is one prediction?
So it's taking in 168 time steps, which is 168 hours, which is 1 week, and then predicting out 1 week.
So you probably need a week in between your two data sets just to make sure that there's no overlap. Like the very first time step of your. I guess it doesn't matter if your data are completely separate. Like you don't ever do any overlap.
Yeah, because I mean it does very well on the regular weeks. It's just the holidays. It's not.
Is it the whole week of that holiday that it's bad?
No, just specific like Christmas. Problem is the week before is no different before a holiday versus a regular week, right? So it has no. If it's only learning the week ahead behind, it doesn't know when to expect the holiday, basically, right? Because it looks there's nothing that's saying
in there.
Yeah, the week before Christmas looks no different than.
Correlate each other out of correlation. Like this is times 3 times 2.
Yeah, so the way that Fast AI dealt with that was day of the week, month of the year.
Yeah, days before the next holiday, all that stuff.
Even just day of the week, month of the year, or week of the month of the year could help, right? Because it would notice the 5th week in January or the 5th week in December is always weird.
So even if it, so that this holiday only comes once a year, which means I only have 4 instances of Christmas. Is that enough for it to learn? Will I have to? Because that was my question. Because otherwise, I have this LSTM, right? The LSTM, this is where I messed up. It only remembers the previous 168, right? It has no memory of the rest of the year.
Yeah.
But then when I use the ANN, it's supposed to remember. So what's the whole point of then training on all the, if it's not going to remember past the 168? Like, so how does the ANN know versus the?
What's ANN?
Like it's just a regular artificial neural network.
Oh, okay.
Is it just because it knows there's these number of days before the holiday, right? Is that how fast I did that, right?
It's just you like specifying how big your input is. Like you could make the LSTM go further back in time.
Yeah.
168 days. But for the I forget the acronym, whatever it is, like it's just if I'm sure if you trained it on the same length of time that you're feeding it to the LSTM, like the results would be pretty similar.
Wait, so
So like, yeah, it's just all about like how the input is being broken down, like how
Right.
far like back in time you want to go for like a certain prediction.
okay.
Um,
But
so-
and then you just take the previous prediction, right? Because you're not even going back.
I mean, I don't know what variables Jeremy was using for fast AI, but like you can define like really whatever you want.
Typically, or at least I think in Jeremy's case, it was only the data for that one day
Right.
that was the input. So the input was, it's this day of the week, this month of the year, this many days until holiday, that sort of
Right.
stuff. Those were the inputs.
Right.
It wasn't, and the predicted value for all the previous days of the week, which is what an LSTM would give you. The LSTM is all that information and what happened throughout the whole previous week.
Well, couldn't you do that with like Jeremy's though? Like you just add, you like double your amount of
Yeah,
inputs,
you would just
like,
have
keep-
more inputs, sure.
Wait, are you saying feed that to an LSTM and then that way you have the 168 plus?
No, I think what we were saying was, in addition to saying it's this day of the week, this month of the year, and this many days to holiday, but also say yesterday's sales were this, the day before sales were that, the day before that sales were that. Like have all of that as one single input into the feed forward.
You're going T-1, T-2 kind of thing in that.
Are you guys talking about Rosman?
Yeah.
Yeah.
Yeah, so it's a regression, right? It's not time series.
Right.
Time series component is coming from those features.
Yeah.
Only that. It's a regression.
Yeah. So his suggestion was to be able to predict a week ahead, take the prediction, then feed it back in as actual value. Right? So we do that over and over for a week. And because I need to be able to predict not just one value, I need to be able to predict every hour for a week. It's 168 hours. So that way, you know.
But as David was saying, can you give the 168 hours as T minus as one of the 168 inputs to the model?
Yeah.
I mean, I
So
can
how-
show you sort of like what I was doing with the financial modeling that I was doing. You know, the time series that is just like, doing something. And you're at this data point, right, in time, that this is future, you don't know what it's gonna be.
Yeah.
You wanna predict the future.
Right.
And what I was doing is, as input, I was taking this far back in time.
Yeah.
And turning that into an array.
Yeah.
And feeding all of that in as input.
Yeah.
And expecting that it would predict a value.
Right.
You could expect that it predicts, 20 values
Yeah.
if you want, and then just make your loss functions out like RMS error of all the values.
Right. So if you're feeding in this subset of time steps, basically, how is that different than what the LSTM does? Isn't that the whole point of LSTM is to feed in all these points that then affect the future versus just one value? Isn't that what LSTMs are like built for?
Sort of, except that the LSTM takes this value, and then it takes this value, and then it takes this value in order, and it's updating a hidden state over time as you build it up.
Okay.
And so, like, I don't know, like, theoretically, whether there's a benefit to that.
Before you raise one question. So like if the LSTM is only learning this 168 previous, right? But we're still training it all of this. That means it has to take some of this going beyond the 168 into account. Right? That's what's the whole point of.
Yeah, so like this is one sample. Like there's another sample that is this sample. And then another one that's like this sample. And so over the course of training, you're giving it all of them. And eventually it learns that when I see something that's like a squiggle like this, that means that it's probably going to do this.
Right. So does that mean it's remembering past the 168 or?
Yeah. The weights of the network are
Okay.
sort of like acting as the model of the thing, the underlying generating function.
Okay. So that means if it's seen past 168, at some, even a minuscule amount, it must remember a holiday. So if I can give more input to that holiday then it should be able to take that into account, right?
Only if you specify that.
Yeah, you have to.
Yeah,
So with the entity embeddings, can I?
Yeah, so like if this day here were a holiday.
Yeah.
There's nothing in this vector that tells it it's a holiday.
Right.
It could be this vector or this vector. You don't know how far out you are to a holiday,
Right.
unless you add that in as a.
Yeah, that's entity embedding, like days until the holiday.
Yeah.
So then that way it will know, okay, it's seen the holidays last year, the year before, and expect the holiday.
Yeah.
Coming up.
Days until, days after.
Yeah.
Yeah,
My
and
only
weekends and whatever, right?
Yeah, my only problem is it only sees that one holiday 4 times out of 4 years.
But maybe all holidays are similar.
Actually, Thanksgiving is different. It lasts 2 days versus one Christmas and Labor Day and Memorial Day. So they all have their unique behaviors. And it's not just the holiday, but the days after people's buying patterns is different. Because people. Yeah.
Sure. So you want like days or hours? Right? You want hours.
Right.
And maybe you want hours until second.
Yeah.
Well,
Yeah.
because then you could get things like, it's a 2-day holiday or
I
whatever.
mean, that's what FastAI does, because right now I only have one entity embedding, which just says if it's a holiday or not, and it's not picking up anything on that. It wasn't able to improve on the holiday on that. So basically all it says is, there's a.
Is this particular
day is a holiday, exactly.
Yeah, it needs to know
How many days till
how
the
far
holiday?
until the next
Right.
one, maybe how far until the one after that as
Yeah.
well.
I think, yeah, so that may improve.
But then even just saying, that it's this day of week, and then this, hour a day.
Right.
This, month of year, something
Yeah.
like that. Those things are gonna be important too, because then it's gonna
Yeah.
learn the seasonality that like,
It has picked up on the weekly seasonality really well, but it's just the holiday, it's completely broken.
yeah. And the thing that's cool about this is you can do all the things that the Boston people do too.
Yeah.
Of like, find out what the weather was like.
Yeah.
Find out.
No, if I just use FastAI, first 72 lines, I'll give me the data in the exact format I need, and I just feed it into the LSTM or the FastAI.
Well, it'll give it to you the day wise. Yours is hourly data.
Oh,
theirs was
yeah,
daily
that's true.
data. But like, it's very similar.
Yeah,
Very similar. But in terms of like,
Until helpful though.
what's that?
Hours until holiday. They usually use just true or false. Is this the day before? Is this 2 days before? 3 days?
Yeah, I think that's a similar thing. Like you could enumerate is this 7 days before? Is this 8
Yeah, but
days
everyone gets a separate feature, not like you get total hours, like 48 hours.
I think that's.
It'll still work with you. If you just give it a number of hours.
I think they both.
Yeah, but then you'd have to, so if your data is, like how far ahead do you want to go for holidays, right? Because holidays could be a couple of months until a holiday.
If it's 1,000 hours until holiday.
Yeah, then it probably doesn't matter. Like, it's going to take that number and it's going to be.
What do you think it would be? You think it would be able to build like exponential?
If it's doing an entity
Bell curve.
embedding anyway, like if these are discrete, it's doing an entity embedding, then it's essentially doing what you're saying.
Oh, okay.
Every single one
Okay,
of those
so
is getting a
It's
different embedding.
going into entity embedding.
What?
Not a regression.
Not regression.
What about, all right,
But you could do it as a regression value.
sorry. What about Narayan's suggestion of just training separate models for each of the holidays and then doing like a if statement and then submitting
That seems harder than this.
rather than
Right, because you've already got the example from Rossman that is basically this. And I think this is really flexible too. Like,
and you're saying I can put this into LSTM and it should still work.
I would just use the feed-forward network.
The ANN? Okay. The only reason I'm asking is I already built, like here, this is the, so it does really, as you can see, got the pattern really well, but it is just.
Which one is which line?
See, you can't even tell. Red is real and blue is the prediction.
Okay.
So it's feeling, even regular days, it's getting the pattern. But as you can see here, July 4th? That's a holiday. It completely blows it because it has this.
What are the colored in bars?
There was two standard deviations. That's the range it needs to fall within. So the pink is.
So business people are saying if it falls within this range, we're happy.
Well, actually, this whole idea is to be able to set us an alert or alarm. So if it falls below, we need to get alerted that there's some issue and the order volume has dropped. So it's all about alerting us to issues in the sales or the system. So that's why it needs. If it's below the bands, that means we know there's an issue.
Yeah, that one's never gonna work. Great, this one.
Yeah, I don't know what that was a weird pattern. But this is generally most of the weeks look just like this. So as you can see, it's gotten a pattern, weekly patterns.
So if you only get alerted on holidays, then there's not that many holidays.
That's what they were saying. Oh, okay, here's the problem though. I'm competing against this machine learning guy. He has like 15 years experience. Our models are exactly the same. So for me to beat him, I need to get the holidays. Because others, they're using his. So for them to use my model, I need to beat his model. And since we're all the same, the only way to beat it.
Yeah, I think this will do. I think this will give you the special behavior when there's holidays.
Good old fashioned model showdown.
But I don't know that an LSTM is necessary.
Yeah, and like
The
how
only
would
reason
you?
I wanted it is because I've spent like 2 months building it.
Yeah.
So I'm like, damn it, can I just feed it? But yeah, if not, fast AI is a lot.
Well, I mean, you
easier.
can put these embeddings into an LSTM.
Yeah,
too.
yeah.
There's no,
Once I
like-
make the embeddings, I can fit into both models and see.
Yeah, how would you put in embeddings with the time series data? Would you just like concatenate them and then see what happens? Like if you were gonna put it into an LSTM.
he's already putting a vector into an LSTM.
Yeah, but I'm like, yeah, like putting an embedding onto the,
See-
because the embedding isn't
Using Keras.
Yeah.
isn't technically like time series. It's just
Yeah,
a
how do you
series of-
train the embedding?
yeah, like how do you even
Here.
input it into the LSTM?
I actually have.
And yeah, how do you train it? Yeah, I have no idea.
Well, I have an embedding layer right here, and all I'm doing is concatinating that with the regular order volume. So then they're all continuous variables, and the model itself doesn't know what the dates are, right? It just takes in each thing sequentially, right? So then I have the same number of embedding rows as I do order volume. So each embedding row is the holiday for that order volume, and then I feed everything in as continuous variables into the LSTM.
I'm a little confused as to what the embedding.
So this is what my data looks like.
So, yeah.
Okay. So I have a dates stamp, right? And I have number of orders, and I have holiday. So this is some time, a date. This is like 56. This is like first I make them label encoding.
I don't know.
And then I turn this into an entity embedding of 0. Blah, 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 0. Blah, blah, blah. So then this whole row, this part, I feed in as continuous variables to LSTM. Once I get these entity embeddings. So then everything is just continuous and can be thrown into the LSTM.
And the LSTM is one layer of the network. The embedding layer is just another previous layer.
I just do the entity embeddings first. I get the continuous categorical variables that I've now turned into continuous variables. Then I concat them with the order volume, and I feed this whole thing as a multivariable matrix into the embedding layers. Sorry, the LST.
Does
That way.
answer your question? Like,
So there's an embedding for each of those. So it's like in Rossman where there is an
Exactly.
embedding for each of those.
So I
categories.
start here, I do the embeddings, then I get them, then I concat them, and then I feed them into the LST.
yeah.
So then,
Okay, so you're already, I guess, concatenating them, and it seems to work.
yeah, and then when the rest of all these, I can do the same thing. I can just create more embeddings, and
Yeah.
then create more, more wider multivariables, and then I feed that into an LSTM, and then it just predicts it as if it's just order one. Because it doesn't take into account the actual dates. Those don't even go into the LSTM. It's just a sequential sequence. It just expects the same things in the sequence.
Yeah, I would try that before trying the fat, because it seems like it should be pretty simple just to tackle a few more.
Exactly. I already did the holiday, so now I just need to create embeddings for this stuff, and then try to send that in.
But I mean, when you did that, did it improve anything, Dick? I mean, were you able to get any improvements by doing this?
No, because like you said, it only right now my embedding only tells it if it's a holiday or not. Like, is it Christmas or is it a regular day? So it only sees the Christmas thing. Oh, because the week before looks the same, regardless if it's a holiday or not, right? The week before Christmas, so it has no way to know Christmas is coming up unless I have this stuff, which is saying day still Christmas.
Yeah.
Then it has a chance to learn. Otherwise, it's only.
These too, day of week and
Okay.
well, maybe not day of week, but right. So if this is day of month, then month.
Yeah, because otherwise, every week. That's pointless, but this is Christmas. But this week is what it's going off of, and this week looks the same regardless of whether this is a holiday or not a holiday. So I'm using this to predict this, but if this looks the same all the time, it's going to have a hard
You
time.
can't use last year's prior. You have 4 years worth of data.
Yeah, the thing is, it only
Past
sees this 4 times, right? Versus 250 others. I don't know if that's enough. I mean,
Yeah, but you can get like
But you still go hourly for each
like,
one
so
of
like
the days.
those
Yeah.
features. You can also go back to the prior year, to the prior Christmas, and put those in and see what you're gonna get. You also have 3 more times like that.
right.
So that's like you can. Those are your do that 3 times for each or 4 times for each year.
Yeah.
That'll give you sort of a trend for that time period.
So you're saying create another embedding with, what's it?
Now have that embedding.
Yeah.
But like you can now have you can use so just random time periods. Use the same say 1,000 days or 1,000 hours before Christmas.
Right.
Use that 1,000 hours before Christmas. 2015, 2016.
Yeah.
So you have like all these features for each year. So you know that the next year, when you get to that
What's
1,000 hours before Christmas this year,
Yeah.
you have the same feature data set.
Right.
Month 0, January.
So that should be consistent in theory if you assume every year is consistent.
Yeah, so I think if
Okay,
I can
fine.
feed it more of the embeddings, I think it'll have a better shot. Right now, it's just feeding
0.
whether it's a holiday or not, so that's not enough.
So like I'm sure
One question. I was-
like 2008
Oh, yeah, I was just
Christmas
saying.
was vastly different from say 2007 Christmas because
Yeah,
of the
actually,
financial crisis.
Oh, I see what you're saying.
So like it's not necessarily going to be.
Yeah.
I guess in economic,
I don't know
so
how they're
econometric terms, it's like the
implementing
wide sense stationary,
Yeah.
that's what they call it.
Well, the
They
thing
actually
is,
waste
the yearly
memory
data is
without
also,
using
right? Charter's yearly volume has changed year from year, so
For the category,
this,
each one is a category.
wherever this is, maybe lower in
But it
2016,
stores the weights.
and then maybe somewhere here in 2018.
You have to
But
tell them how
but
large
the
they
relationship is the same.
Yeah,
right?
exactly.
So
The-
Yeah, all the
Say that
business
the
look the
embedding
same,
size-
all the things look the same.
Like maybe
From
the,
the
you
years
can
12.
adjust like
Yeah.
you can use maybe like
and then whatever.
well, some
Math
difference
zero.
equations, some difference
Yeah.
like
Well,
say
it
relative
knows-
absolutes.
Right.
So then
I mean,
that should
Right.
homogenize your different year
Yeah,
trends.
plus it knows which strip it is from the previous week, so that way it can adjust.
You
this.
don't need it all.
embedding.
Yeah,
Yeah, that's
I think it'll have a better shot. with this.
Yeah, no, but like David has a certain point, like
Much smaller.
you know your holiday, you know your time period till that holiday.
Yes,
And
exactly.
then you can sort of extract that same data out each year, and then you'll have 4 different timestamps
Right.
that you can
I
train
want
against.
that.
Four vectors.
Wait, no, were you trying to say something?
Four vectors.
I was going to ask, I mean, if we do the Rossman style, I mean, there is that Rossman style kind of architecture only predicts one value at the end. But you're
Yeah.
wanting the 168 values and in order, I mean, in order of the time. So
So yeah,
I
remember,
don't know how you would just go to a Rossman style kind of network.
well, Eric's suggestion, remember, was to take that prediction and then feed it back in as an actual value, and then do that over and over again,
He gave like a-
168 times.
What was his?
But I don't know
But that's what an LSTM should do it for you.
right. So yeah, that's the thing. Is it any better using that, or is it? Yeah, I guess that.
Yeah, like ultimately you have to try both.
Right.
I would say
Yeah.
since you're already far along on this, just go
Well-
the extra like little bit to try this.
Well, the thing is, like,
For
once
someone
I
like
get
you don't need
this
as
this
many-
stuff, feeding it to FastAI or the LSTM is the same, right? It's just
Yeah,
it's the same
hooking,
thing, but-
yeah, it's like hooking up the different
I think
Right.
he just capped it.
so I think either one I can try both.
Yeah.
So the
Yeah, it's just that FastAI has some of that like machinery already built
Yeah,
to do like some of that stuff for you.
yeah.
why do you need hours until holiday to be embedded there? Isn't it just continuous variable?
If it's not, I guess, so the time period, like this 1 week is not the same as the next week, because like Christmas makes everything special, right? And he's concerned about that special time period.
You want to do those in days.
And he wants to like, his prior training data, if it's similar,
His data is as
I know
hourly.
it's
Hourly,
hourly,
but
but
you
you
can
can
use the
still pass
same-
it days
how many hours
before.
before for the past 4 years, they should be the same. But like taking a random week,
That's
say in the
not
summer,
what
that has no holidays, will have a different.
I guess
distribution.
This is
But
more.
why it's a categorical?
Yeah,
More
I
days.
guess.
I don't know how many
It's a
holidays
big
there
difference.
are. Yeah,
Which part,
like if there are quite a
Hours
few
until holiday.
holidays, then
In
Hours
FastAI,
to
don't
holiday,
they say if
if
you
there's
can
like
turn it into
multiple of them in a
continuous,
week, then
to use it as
you need
continuous,
more
and if
resolution
it's
to know.
sorry, if you can turn it into a categorical, to use it as categorical, if not, use it as continuous.
continuous.
So another question is why does this have to be categorical? Can't it just be?
Yeah,
FastAI?
so is it the case that 24 hours before a holiday is important versus 23 hours? Like they're categorically different from one another? Or is 23 1/24th of a difference? Like, is it really smooth? Like,
Well, then it becomes like, do you
the
care about the
amount of
hours or do
time
you care about the days?
That's why I was suggesting
Yeah,
the
yeah.
days if you're gonna be categorical and only do a few of them. And
Because
I thought-
if you do like up to a cardinality of like
Yeah,
40, it did.
but like, you
Oh,
probably
there was, like,
also
a
want
certain-
like hours until close, right? Close of business or whatever. Do you have that in there? Like,
I don't know if it's online data or online purchases, so they can buy it anytime.
well, yeah, but they're not buying from Ethiopia, they're buying from like our.
Yeah, so then it does go down
Yeah,
during the middle of the night, but
so like if do you have hour of the day in your embeddings somewhere? Yeah,
no,
you must-
no, because it doesn't care. The LSTM ignores the timestamp itself; it just expects sequences. So I will need to create a
Yeah, you
embedding
need to
for
separate
our.
them.
you feel open, so.
Yeah, definitely. So yeah, I will have to create a entity embedding for that. But I think part of the reason is, in FastAI, they say if it can be turned into a categorical variable, you should turn it into a categorical variable because you get a
Yeah,
higher dimensionality.
Yeah, so, like,
representation.
hour of the day is of the example that I was saying for hours to holiday. Like if it's 1 hour before closing, that is different, like categorically different than 1 hour after closing. Like
Yeah.
it's not a smoothly varying thing. Like it's not
Okay.
like it always drops by 5% or something. It's like something drastically happens at certain time periods. So that's why categorical makes more sense.
And the other thing is, what I'm doing is I'm taking categorical variables, converting them to continuous, and then piping them together with my continuous order volume, right? But online, a lot of the people had built separate models and then just merged the models. That shouldn't make any difference, right? That's pretty much the same thing.
No, I mean, I think yours is smarter.
Okay.
You're
Because
just making a new signal here for a new model, right?
yeah,
It's
you're
not right
you're
here.
allowing your model to engineer the features
Right.
rather than building separate models where you have engineered what you think are the important features.
Okay.
The only thing that you put into this that you think is important is you're saying, I think holidays are important, and I think days of the week are important, and like nobody can argue with these. These aren't like super features.
You're identifying them. You're making them more explicit.
With LSTM though, if you're starting to skew a little bit at a time from normal, and after a while it's a lot different than normal, LSTM may not detect that because it's looking at the previous data, but it's been skewing so slowly, moving from the normal weight slowly. So and if you're looking at only, I don't know, how many hours are you looking at?
How many days are you trying to predict? Like, are you trying to predict how many hours or how?
A week ahead,
Just-
but
It
it has
predicts
to
a
be
week
for-
ahead, but every hour you're going
Every
to run the
hour.
model again with the newly updated data. So
Yes.
it won't trend.
But if you're,
Well,
I'm saying from one side, it's a good thing that it's not just looking at what it learned from what you trained it on. From another view,
It could hallucinate and then
yeah,
drive itself off of
if you're trending just slowly off of your trend, it might not detect that as it might be predicting according to your current trend versus what you trained it on, and then you might be slowly skewing it. If your volume is going up or
But
going
yeah,
down
no.
slowly.
So I guess he has to make his whatever his other features are, like relative to some baseline that would change over time. So you have normal, so it becomes normalized in that
Mhm.
sense.
Well, that's what LSTM will normalize it for you. But if you're not using LSTM and you're just using the features, including these and the hour of day and the time, then don't normalize it at all. The gradual increase if you didn't have enough data, not the same gradual as you trained it on, but it starts rising a little more, and now you're not predicting the right thing anymore.
well,
I think it's going to suffer the same thing that like regular forecasts suffer from.
Yeah.
Like
Yeah, no,
5-day forecasts are not as good as 3-day forecasts, which aren't as good as 1-day forecasts.
it's good to
right?
have. So it's good to have both the features, all of the engineered features, and a little bit of LSTM.
What are the engineered features?
are they embeddings?
Embeddings.
These go into that. These are the inputs, right?
Yeah, yeah. So there it's combination.
Versus not having LSTM.
No, I think your idea here was pretty slick. Like, you're just trying to model this in the holiday cases. So yeah, having those things adds, overall add value, right?
I'm not sure what you're saying.
No, I guess
I
like
think it's a compliment. I don't know.
No. But I think what you're saying is right. Like you're trying to model your odd holiday case or
Yeah.
everything else, and like by having those features that Dave pointed out, that they will help highlight those holiday cases. And so by adding you're just having the direct timestamps and all the features you were mentioning before, you can't distinguish between holiday and just not
Yeah.
holiday.
Yeah, that's
So
true.
this will give you
Holiday-
the added
Holiday versus
signal.
not holiday is just strictly new information. The network's never known.
Right, exactly. Whereas this information that
This
you
is just
mentioned
data
will-
enrichment. It's not
Yeah.
feature engineering.
My only concern is
Smith enrichment.
But it'll highlight it.
Yeah.
Definitely.
No, and like generally speaking, I would say if you're tempted to build multiple models, like second guess that decision, because it's almost always better to build one model bigger with more information. Like old school stuff would just saturate or like things wouldn't work. Like deep learning, just like more data, more information is like almost always better.
My only concern is the number of holidays it sees, right? Is that enough for it to,
I know.
yeah,
And it probably matters which holiday too, right?
So
Like
you can,
dynamics for Christmas is far different from dynamics
Yes.
from 4th of July.
yeah.
you can give it one generic one for all holidays, and then
Days till Christmas or days till.
separate them also, and then it'll decide, what.
Yeah, I mean,
Can I
that is the
use
brilliant
this-
thing about deep learning. You
Can I
throw
use
things at the wall and you find out what sticks.
And
And
use this,
What if I make up data? Is that risky? I'm trying to get make up data, like create additional data, because this pattern repeats every year essentially,
Right.
but slightly different. Like make up data, basically create more years of
Why
data.
don't you just run more
Like-
debugs or something and,
But then,
so
and
you
give it
want
more,
you want to engage in data augmentation.
yeah,
How
But nobody has a good plan for how to do data augmentation on time series data. If you
Yeah.
come up with it, it'll be probably specific to your data set. But you should definitely do data augmentation, and like it's just a force multiplier. It just
Yeah.
gives you
But how
more
would
data.
he do the data augmentation here?
Yeah.
No. That's what I say. It's like specific to
you're
your
adding
data.
a lot more risk by doing that because
Yeah.
you're totally.
If you're
goofing
well,
it
yeah.
up.
because
Yeah.
here's the other thing. It depends. Right now, I have for charter, I have 4 years of data, but it's not. This is not the only. So they bought Time Warner Cable. They bought BHN. They only have like a year of data. So I need to build the same model for them. So
Well, you can, if your data follows similar patterns to their data, you can pre-train on yours
Oh,
and then do transfer learning on
And
theirs.
then, I'm sure you could like even.
And you could maybe even do the same kind of thing if you have a competitor or some other data set that goes back more than 4 years.
Yeah.
Pre-train on that data set, and then
Is your data also like? Is it other features too? Like,
I mean, because how different are
do you like gender, for example? Like, is it more?
No.
or-
all I have is order volume and the date.
but how
So-
different are charter sales to shoe sales or car sales or whatever? Like, there's got to be tons of sales
Yeah.
data for the United States
Yeah.
that you can use as a pre-training, and then that's
And
another
volume data,
form.
do you
It's
have,
not
like-
data augmentation, but you could use it as pre-training.
Yeah, that
Is
is
your
true.
volume data also like separate out by plan? Like I'm sure there are different plans for different things, right?
Yeah. No, but I think these are good suggestions. So, thank you.
Yeah.
I'm not trying. Sorry, I didn't want to.
No, it didn't have anything.
It's really weird. It's like, I guess, to be honest. So my background is signal processing, and it's like the whole mindset is different when you're trying to. I guess the neural networks is like this qualitative. You're trying to add features, but you're not trying to look at the data itself. Like I was like when you mentioned holidays, the first thing that entered my mind was holidays are not wide sense stationary. Like in the sense that you can't take any arbitrary time slice and the graph will look the same as around the holiday. Right? It'll be totally different. So like a lot of models will be just out the door because like they have the assumption that like any given random slice of time is the same as another random slice of time.
Yeah, isotropic stationary data.
So now that we fixed this, who's good at chemistry?
Chemistry. Is this
I gotta watch
for
you.
your watch, do you think?
It's not hard, but yeah, I need to learn chemistry a little bit.
Maybe you want to do a Fourier transform to get the trend of the variation.
Oh yeah, to get the
Yeah.
So what you described, like what you're
to get
describing,
the periodicity out, like to
Right. And also these figures, right? So since you are okay to make the prediction within that full sequence,
Bounce, yeah.
you don't really need
No.
to match all these, right? It's okay to match a smooth curve.
or a moving
If you
average,
do
yeah,
a
have a moving
Fourier
average. Just
If it is smooth smoothing out the.
Yeah.
On the actual volume.
Well, it depends how much. You smooth it out too much, that's a bad thing because you're losing your hourly trend.
Yeah, but you can control that, right?
Right. So you have to watch.
So your neural network won't have to do a lot of work.
Right.
So do you have it predict a whole week in advance, or do you have it predict one day and then you run the model on itself to predict the week?
All right, so I'm predicting ahead the whole week. Because when I predict ahead by hour, is that what you mean?
Yeah. Do you just predict ahead 1 hour?
Yeah.
I tried that. Problem is when you do that, it learns the outage. So when there's an outage, the order volume drops. So then it changes its prediction. It adjusts its prediction lower, which means it won't send an alert out. We want it to be wrong on the outages. So by predicting out a week, then it won't be able to adjust for the outage, and it'll keep alerting us when there's a problem. Because otherwise every hour it's going to adjust, and it'll stop alerting us. So that's the whole thing. Like we want it to be right on holidays and regular days, but on outages it needs to be wrong. And when I did it hourly, it was able to incorporate that into the prediction, and then we stop getting alerts.
And outage means a point where you have no
When the order volume drops,
yeah,
so it
volume
could be
is zero, the result is, or the amount sold is zero.
0 or significantly lower, beyond the bounds. So then we know there's
And
something
then
wrong.
you're saying if there's an outage when you do your 1 hour prediction, it'll predict it as being an outage.
No, when there's an outage, that means it will see that outage. That means the next hour it will predict significantly lower, which means it's now within the bounds again, and it'll stop sending us alerts. And we don't want that.
Are you doing any pre-processing of the
That's-
data?
that's
Do you
the
know when there
shortfall
were
of
outages?
LSTM that I was-
Yes, I do.
The what?
And
That's the
are you
shortfall
patching that data
of
up
LSTM here that I
so
was trying
that
to
you're not training on the outage data, but you train on the smooth version?
That's the
instead?
thing. I initially I made that mistake, and I didn't train on outages, so I do need to fix that. But the outages are fairly rare. But
Okay.
yeah, I do need to remove that. I think that's a good thing you mentioned. I forgot about that. Yeah, I do need to remove some of those outages.
Well, if you train on data that doesn't have outages,
Mhm.
then I don't see a problem still.
Because so say I'm predicting ahead of an hour, right?
LSTM will
It'll still be able to adjust if it's
be
only making
predicting
an hour
the
ahead.
current data.
Because it sees that the prediction is lower, so then the next time it'll predict slightly lower. So it starts adjusting itself.
So if you
I don't know, does that make sense? It's able to pick up on the outage
How often are you alerting?
once an hour.
So then,
you threw the alert,
Yeah.
and you want to re-throw another alert in an hour?
If the thing is still occurring, if it's still low, they want to keep getting alerts. Because if
Okay.
it stopped getting alerts, then everybody thinks everything's fine.
Okay.
We want to keep telling people, no, there's a problem. So
so wait, the end game is to identify when there's an outage.
yes,
That's the end.
that's the whole point of the prediction.
or some sort of anomaly.
Before they were doing averages, but then it doesn't send. It's all about it's to alert there's some problem. So average was not a really good way of doing it. So this uses more intelligence, taking into account previous data. I hope I didn't give away all the our secrets.
Yeah, I'm gonna go start my own chart now that you said that.
Right. Yeah. Well, yeah, that's the whole idea. So if it's too good, that's a bad thing because that means it's figured out the outages. Like, I don't want that either. So it needs to be a little bit off, but I do need to clean the data.
I was trying to do the same thing with the transaction volume and decline volume. Like if the decline volume is all of a sudden completely different than usual for credit card transactions, then start alerting. But usual fluctuates a lot. just the same as sales. The same model here.
By the way, I think you're gonna like my next project. I'm building a Splunk AI to take Splunk data and then alert to issues and predict outages and get the right team on and stuff. So
like-
that's gonna be fun.
A non-machine or non-deep learning approach would be like you can model equation of your sales or some signal, and you add some additive noise. Depending on, you can set your variances.
You just
your means.
You just give it a threshold. Above
Yeah.
or below, right?
Right, yeah.
With a standard deviation.
That would be the most simplest, right? Just have one.
One equation.
Yeah. Just
Yeah. Yeah, you give it all the inputs and it's just regular linear regression.
Is Narayan Splunk? Nope. No.
still here.
Okay.
Bye.
It should still be on.
It's still on? Are you familiar with the Splunk AI toolkit, machine learning toolkit? Oh, it is now. Yeah, let me. Over there.
You still there, Narayana?
What is Splunk again?
Splunk is like, I think Andre could probably describe it better.
Okay.
I think you might be gone.
I think you may have mentioned this once before. I just totally forgot now.
Yeah, I downloaded it for a bit, but you send it all the logs. Well, it has agents running on all machines if you want. You install the agent, it forwards the logs. It stores them somehow in like a big data type of structure and indexes them by
So
like
sort of like Elasticsearch in that respect.
yeah, but then not by like no.
Yeah. Okay.
You don't, not that type of index, because it still has to, it's pretty efficient. It doesn't store like indexes so you can just look for a specific event and find it really, really quickly, but you'll have to scan a good amount. But they figured out how to do it pretty efficiently, pretty quickly. And you can do things like sampling, so like
Is it meant for like
Check
time
out.
series data especially, or for
times, not specifically, but you could, like, and it has nice charting tools and graphing and statistic tools. So you can build dashboards, and it has a nice UI to do that like easily in a minute. You can have a nice chart bucketed by either minutes, seconds, or whatever you want.
So are you familiar with the machine learning toolkit?
No, I did not.
You haven't used it? Okay. 'Cause I'm debating whether to use that or build my own model and then type the data to the.
Yeah, I don't know how advanced whatever they have in there is.
I'm hoping it's not, so I can build my own model. I don't want to just use
Then
their.
Somehow we'll have to call Splunk's APIs
Yeah,
to extract the data, which
Yeah.
it has APIs to do that.
it is, okay.
Yeah, like for us call to
Yeah.
to do the searches.
Yeah, as long as you can feed the data from
You
Splunk, the
yeah.
model then.
But also you can have a saved search in Splunk that runs on a scheduled basis,
Yes,
so that when your model
Yeah.
is when you want to run your model and
Yeah.
with the current data, it can go against the saved search, and then if
Bye,
it's
Narayana.
available right
Stop
away
by.
instead of